Hey everyone, welcome to Pixel Session 4. I'm Anjali and I will be covering how to do post-processing and basic scripting. So in this session, I plan to help you guys understand what basic game objects are, what colliders are, and rigid bodies. And then I would teach you guys how to make glowing objects using something called emissive materials and a package called post-processing. There's also the basic scripting from using C sharp, and using this, we would make the object move or disappear on collision. As you can see, I've set up my Unity editor this way. I have added a AR camera and an image target. These are available in the Vuforia package that you can insert into this editor. So on doing this, what is a game object? A game object is basically a component with whatever desired features you wish to have. It can have a mesh to give it a basic shape. It has colliders which detect collisions, and it can have multiple components which you can add or remove based on what you prefer. And as I've said, colliders are something that detects collisions, and these are extremely important, without which you can't do anything after detecting it. And these rigid bodies are the only things that can collide with each other. Hence, this is also important when it comes to collisions. And these have mass drag, angular drag, which you can adjust, or you can even uncheck use gravity if you do not wish your rigid body, which should ideally obey the physics in game. You can uncheck use gravity if you do not wish that object to uh, obey gravity. With that being said, let's make a glowing object. So I will take the instance of a sphere and place it over my, adjust it 0.1, and then place it on my image. Once that's done, let's create the emissive material. For that, go to Assets, right-click. It's preferable to keep your assets well organized. So create a folder and name it as Materials. Then right-click on the folder, Create, go to Material. Give this a name. I shall give this Emissive. And here, set your color using albedo to anything that you wish. I will go to some tone of blue. And this is important. You have to make sure you check the emission box, without which you cannot get an emissive material. And emissive materials are basically a material which emits its own light. It need not depend on the light source that's in the game. So here too, we can set it. And I shall put this emissive material onto my sphere. And this you can do it by dragging and dropping it. You can adjust your material as and how you wish. Now that that's done, I am going to make a prefab out of this. Just to explain what a prefab is. So right click, create folder, prefab. And in order to make a prefab of an object or a prefabricated object, you take your desired object, drag it into your prefab folder. This can be any folder. It need not be named prefab, But on doing this, you create a prefabricated object. And this is useful as a pre-made or object that you can use in your game to instantiate randomly and so on. Once that is done, we will go and go ahead and add the post-processing package. For that, go to the Windows panel, Package Manager, go to Unity Registry, search for post-processing, and install it. This is something that will allow us to add effects to our videos or the cameras, and it works in a way. It works just like a filter on your camera, and this is what will help us give the glowing effect. Once that is done, go to your sphere, add a component. We shall name this post process volume. And this is something that's going to, this is one of the few things that's going to help us with the glowing. Go to your AR camera. Here too, add a component called post process layer. Once that is done, make sure your layer is the layer that you require. But for now, I shall name it everything. Go back to your sphere, click on new, and this creates a sphere profile. And add your effect, go to Unity. We need the bloom effect in order to get the glowing thing. And make sure you click on is global in order to get the effect. You can adjust the intensity as and how you wish. The more intense you keep it, the more your glowing ball shines. And there you go. This is how you create a simple glowing object. And this can be anything. It need not be a sphere. It can be any object as long as you make sure it is global is checked. You have the bloom. You have the bloom's intensity checked, and you have the post-process volume on your object and the post-process layer on your camera. And make sure your layer is set to everything or whichever layer your object is in. Now that that's done, let's create our scripts. But before that, let's create a reference object. I'm going to make a capsule, adjust its scaling. Drag it to like one side. In this capsule, I'm going to turn it into a rigid body because I need this capsule to collide with the sphere later on. And I will uncheck use gravity because I do not wish my capsule to keep falling down. Now that that's done, I will also make the capsule's collider as is trigger. And this is important because this is a variable that becomes true when it detects a collision. But we should make sure that you do not add check is trigger on both the sides because then it causes an error. Now that that's done, go to your assets, right click, create a folder called scripts. Again, right click, create C# script. Now you have to make sure that once you name your script, you do not change it later on, or else it will cause an error. For instance, I shall name this the collision script. So collision. And as you can see, it has a public class called collision, the same name as your script. If you rename your script, you have to make sure you rename this side too. If you do not do that, there will be an error. So now open this in Visual Studio. So you notice this void start and void update functions. These are the two most important functions that Unity uses in every script. I shall explain this in the next script. For now, we do not need these two. What we do need is something called onTriggerEnter. So once you type onTrigger, you find onTriggerEnter, hit enter, it fills it up for you. This is a function that Unity calls upon once it triggers a collision. Once it detects a collision and its trigger is set to true, you have it's going to call this function. And here's where we write in what are we going to do once it detects a collision. So we're not going to do much. The only line we're going to script is destroy game object. What this means is that it calls upon destroy function, which destroys the object that's present. And the object that we are specifying is the small letter G game object. We say this to refer to the object that to the game object that this script is connected to. If you cannot mention capital G game object because this is its a type. It's like a class, another type of object, and that's not the correct usage here. So small letter G game object, and this is what allows you to destroy the object this script is attached to. Save it, and then go back to your Unity. Now we need to attach this to our sphere. So once you go to your sphere, take collision, drag it and drop it here. That's it. So anytime the sphere collides with something and a collision is triggered, it will delete itself. Now that's done. Whenever you have a prefab, you need to make sure you override any changes so that whatever change I've made it on this instance, it'll be affected it will be there on all the prefabs. So make sure you occasionally go to overrides and apply all. So let's create our next script. This time I shall name it movement. Open it in your Visual Studio. Here we will keep our start and update functions. Now, what is the start function? It is the function, as the comment says, which is called before the first frame. So that means when your object is created and the first frame, this function is called. It won't be called later on because only update will be called, and this is called every frame. And this is where you do stuff such as movement and observing the input from the user. This is where you usually initialize variables and so on. So for the movement script, I will create a few public variables. First, public float speed. And I can set it to say 0.5 f. Now this means I shall explain why we need to mention this as public in a bit. Float is like numbers with decimals. And in C# language, if you have a float, you have to make sure you put an F at the end. There's no such mandatory rule in the case of integers and stuff, but in case of float, it's extremely important, or else you'll get an error. There you go. Now that that's done, go to the next one, public game object, the type game object, and I'll name it capsule. And this will be our the capsule which we've kept in our Unity editor. So now go to your update function. We need a new variable called float step, and this will be speed into time dot delta time. Then we need to change the position. So we type in transform dot position. So transform dot position refers to the position of this game object, the game object this script is attached to. And we shall write this as equal to vector3. It's again another type of class in Unity, which has all the the 3D vectors functions. Dot move towards. Now this is a special function which, as you can see, it moves from the current position to the target position in max distance delta, and this is our step. So we type in, our current position is transform.position. Our target position is capsule dot transform dot position and step. So we in order to explain what this step exactly is and what time dot delta time is, if we do not use time dot delta time, if we move our object only at a speed which is 0.5 units per second. So the problem with this is that if you have a system with 60 FPS or 60 frames per second, your object moves in 1 second for 60 FPS. Your object will move in 1 second 0.5 into 60 units. That would be 30 units. But if you do the same with 30 FPS, you end up with 0.5 into 30, which is just 15 units. So for the same amount of time, you're ending up with two different distances, so two different speeds. So anyone with a better system would have a better system with better FPS would have an unfair advantage. So in order to unify our playing field, what we use is into time dot delta time. Now, what is time dot delta time? This is the amount of time that the previous frame took. So if I could say, even though not all frames take the exact same time, you could say approximately each one of them are 1 by FPS. So each frame takes 1 by 60 or 1 by 30 of a second. And why this gives us an this unifies our playing field, because in 1 second you can only go reach 0.05 units, if be it 60 or 30 frames per second. And this is why we need to use time dot delta time whenever we have an object moving. That being said, save this, go back to your Unity editor, attach it to your sphere. Now you can notice your movement has two extra parameters given here. Your collision had neither of those, because in here we mentioned two public variables called speed and capsule. And this, if you had mentioned this as a private variable, or if you don't mention it by default, it is private. But if you mention private and go back to your script, it's no longer there. So we do not wish to do that, especially in times when you're debugging your game. So hence undo public. I shall keep my speed at 0.5 for now. Now the capsule has specified none, no game object attached to it. So we need this. We can either click here and select it, or you could just drag and drop. Drag and drop it here. Done. Now we have one last script, and this is to make our sphere go up and down. So new script. I shall name this as bobbing. Now in this script, we will have public, again float, time keep, or let's give it time. And this is the, I shall explain this in a few minutes. Next is public, or let's keep it private, float, timer equals to 0. Then public float speed. Then int up equal to 1. Now your time is basically the amount of time your object or the sphere is going to take when going up before it changes its direction and goes down. So if I set time as 1, for 1 second it will go up, and then the next second it will shift its direction and come down. After again 1 second goes back up, and so on until this object is destroyed. Your timer is basically the thing that's going to keep track of the time, and once it reaches 1 second, we're going to reset it again to 0. Rather than 1 second, let's keep the 0.1. Now go to your update function, type timer plus equal to time.delta time. And as I've said before, this is the amount of time the previous frame took. So you're just accumulating this, adding these time taken one by one in each frame into your timer. And then we're going to check if our timer's value goes beyond our time, or in this case 0.01 second. If it does, we're going to reset timer equals to 0. We are also going to change the direction. So we're going to make up equals to minus up, because when up equals to 1, it's going to go up in the upward direction. But when it becomes minus 1, it's going to go in the downward direction. And this rotates each and every time. Now, the last line of our code is moving up and down. So we need to type in transform dot translate. We can use like our previous code, transform.position equals to transform.position, so on, plus so on and so forth. But I find this easier for linear movement. I just need this to go up and down. It's pretty simple. So translate is perfect for this. And this just requires a vector translation. It's the direction in which I want this to go into the distance and so on. And here I need a new vector 3. this is my vector. The x component of my vector would be 0, y component is up, z component is 0. Because I do not wish to move in the x direction or the z direction. I just want it to go in the y direction, be it up or down. Now that the direction is established, we will multiply this into speed and again time dot delta time. The reason is because I need this to go only in this much distance, in this direction every frame. I do not wish that it goes beyond that. Now that that's done, save it. Come back to your Unity. And again, attach it to your sphere. Here too, you can set your time and speed as in how you wish. You can test your game out and do it. And finally, once this is done, make sure you go to your file, build settings, change shift to Android, switch the platform and build it and run it as we have taught you in the previous sessions. So once that is done, you would get something like this. That's all. I hope you guys understood this. And this session is extremely important because we will be continuing on the same game objects with the same scripts. We will add on user input and how virtual buttons. So user input in order to move our capsule or the so-called player using our phone and move it around, and a virtual button which can spawn random objects here and there. So I hope you guys understood this, and I'll see you in the next session.